Hey guys, I'm Ishal the Intelligent. You've already started watching Learn with Yapi. Welcome. On my channel, you will find educational videos. My specialities will be math and sciences, and I will be covering various topics in interesting ways so you will feel you find yourself related to them. These discussions will be beneficial for students who have a hard time paying attention or feel disconnected from their topic. When dealing with math, I will spend a fair amount of time on theory and background part, as those will be some of the most important videos because they will get you ready for the exercises. Our today's topic is quadratic equations, and today we'll be learning quadratic equations, so let's jump into our topic. So before we do any single thing else, like do any methods of solving quadratic equations or like any single thing else about quadratic equations, forms and different ways to write them and examples and any of that, we need to define quadratic equations, what the word means, what each word in like the whole word quadratic equations, what each word means, just to, get a way better understanding of what's going on here. So first of all, in quadratic equations, there's a word which is equations. This right here. So we need to define what this is. So let's write equations right over here. So an equation. So what is an equation? An equation is a mathematical statement that shows the relationship between two or more expressions, terms or expressions. So it's basically a relationship. It can be in a relationship like 1 plus 3 equal to 4. It can be like that. It can be F equal to ma, which is a relationship between mass, which is right here, force and acceleration. It can be a relationship like 4x plus 5 equal to 9. Well, it can be any of these. That one, or that one. All of these are correct. Like, they're all equations. They're basically just relationships. And one thing you just need to, like, remember in relationships, like, an equation, the relationship between two or more quantities is basically where there's an equal sign right there. If that's there, that's an equation, alright. So, sometimes you might notice there's something like this X right over here. So these are all just letters, but there's something like literally X right there. And it's like came in a lot of questions. You might have seen like find X and this and that. Well, first of all, we need to see what it and like what that X or what other letters like that are. So first of all, I just want to mention they're variables, and the most common variables there are is like X, Y, Z. These are like most of the common ones you might see in questions, like find one of these or you have one of these, and different stuff related to these. So in like an equation like this type of equation right here, which has a variable, this type of equation, like let me write it right over here. 4x plus 5 equal to 9. This equation over here, it's a linear equation. Why? Well, because the power of x right here is like 1. It's 1. So just like, wait, let me write another example for you, like x plus 3 equal to 5. It can be this. Well, the only thing in common, in both of these is that they both have like x. The power of x is 1 in both of them. And so these are linear equations. But we're really talking about quadratic equations here, and we don't really want to get into linear or any other type of equations. So we know what an equation is, and yeah, this is a linear equation, we know that too. But we need to know what a quadratic equation is. So for that, we need to define the word quadratic to understand what, like we know what an equation is, but what does the word quadratic with equation mean? So that way we can define it whole, understand what that is. So in the word quadratic over here, there is another word which is like right here, which is quad. Let's write that down right over here. Quad. So what does this like word mean, quad? Well, it means square. And now, what is it the square of? Like, is it like literally the square right here? Well, no, it's not that square. Not that square at all. It's actually more like the square of a variable. So, quad means square, and it basically means the square of the variable. So what's a variable? Any of these. Basically in algebra we can say like any of these. So the square of one of these. So it's like x squared. That right there. So if you notice, like, the power over here in this linear equation is 1, and the power in this, like, let's like make an equation like this is x squared plus 5x equal to 4. Now this is a quadratic equation. This is an example of a quadratic equation right over here. So basically in a quadratic equation there's like this x squared. So we basically define a quadratic equation as an equation that contains the square of the variable. I hope that makes way more sense now, because we know what an equation is. It's a mathematical statement that shows two or more, like the relationship between two or more terms or expressions. And in simpler form, that's basically just a relationship, between two or more quantities with, like, basically it needs to have this sign right over here, which is an equal sign, like that. It needs to have that to be an equation. And if it's not, like if it's just this, or if it's just like that, well, these are basically expressions. These are not anything more than expressions. And then this or this, like any of these is 1 and this is x, and then 5x or like 3x and stuff. These, or even square, 3x squared. These are all basically terms. So from terms or quantities, you could say, both of them are the same thing. So if from terms to expressions, and then, but because expressions basically are when they have like signs in between of them. So like these are expressions because they have signs. So it could also be like 4x minus 1. This is also an expression because it still has a sign, right? So from terms to expressions to equations, basically. And equations are basically when these expressions or terms, because over here there's an expression and over here there's a term. So, you know, they can be like any of them. When there's two or more expressions or terms in a mathematical statement with an equal sign. Okay, so now that we defined a quadratic equation, which I'll define again for you, a quadratic equation is basically an equation that contains the sum of the variable. This is an equation, those are variables, and this is the square we mean. So that's that. So now I'm just going to give you a little bit more examples of quadratic equations, like there's x squared minus 7x equal to 6. So this is basically x squared, and this is like 7, which is the coefficient of x. So there's like an x squared and x, and this is basically the constant. So it can be written as this, or it can also be written as 3x squared plus 4x plus 5 equal to 0. It can be written like that. Like the constant can be on this side or that side. And that brings us to our next topic, you could type of say. Yeah, our little mini topic, which is basically a form to write a quadratic equation, and it's like the standard form. So let's write that there, standard form. So the standard form of writing a quadratic equation goes like ax squared plus bx plus c equal to 0. So in the standard form of a quadratic equation, the constant is on this side right over here. And there's a 0, like this one right here. So you could say this is how to write in a quadratic equation standard form. And this one really isn't. I mean, it's still a quadratic equation. That doesn't change the fact that it's a quadratic equation, but it's just not in standard form. And when you write a standard quadratic equation, you're gonna write it like, it is ax squared plus bx plus c equal to 0, provided a is not equal to 0. Now what does that mean? So, a is not equal to 0. It's as simple as that. But if it doesn't really make sense, like, why isn't a 0 exactly? Like, why can't it be? Well, that's because it wouldn't be a quadratic equation anymore. So let me show you how it wouldn't be. So if we were to say, let's imagine this were true. A was 0. We put the value of 0 because, we could put a there, we can put 0 there because they're both equal now. So, you could put them in place of each other. So let's put a 0 there. So the a is basically multiplying with the x squared right now. So let's just exactly obviously do that because it's in the same place, right? It has to be in the same place. So plus bx plus c equal to 0. Now when any single thing multiplies with 0, what does it become, kids? It becomes 0. So 0 plus bx plus c equal to 0. And 0 adds with anything, what happens, kids? Well, it's still the same. So, because it really doesn't make a difference, right, guys? So, that is what we get. And, again, what is that? Well, as we can see, that its power right now, the x's power is 1. It's not 2. And, yeah, this is a linear equation, which is basically not a quadratic equation, so definitely not what we want. So that is why this is there. A is not equal to 0 because it will turn into a linear equation, exactly what we don't want. We want it to stay as a quadratic equation, obviously. So that's how you write standard form, right there. Oops. Right there, and you gotta mention that because if you don't, I mean, it's just good to mention it because, you're telling, based on your knowledge, like, a can't not be 0 because if it would, then it would be a linear equation, or, yeah, it wouldn't still be a quadratic equation because a quadratic equation, though, review, it is an equation that contains the square of the variable. And over here, the variable power is 1, not a square. So, that's what we're talking about. So this is how to write a standard quadratic equation, and yeah, that part right there, which is a is not equal to 0, so that's not right. So next, we're moving on now. Okay. So, and by the way, just a little thing, a quadratic equation is also called a second degree equation. Oops. Yeah. So a quadratic equation is also called a second degree equation, in case you didn't know that. I mean, just telling you. Okay. So next we have, let's move a bit more down. Let's write down. Next we have pure quadratic equations. Now, what are pure quadratic equations? Well, pure quadratic equation is when the coefficient of x, which is b, so let's write the standard form, ax squared plus bx plus c equal to 0. Now, the coefficient of x, this is x, this is the coefficient of x, so we're talking about b. If b were to be 0, what would happen? Well, we would get a pure quadratic equation. And now let's test this out. So like b equal to 0, put that in there just to see, like what we get. How do we write a pure quadratic equation? Well, ax squared plus 0 instead of b, and then x plus c equal to 0. again, any single thing multiplies with 0, it's 0. So ax squared plus 0 plus c equal to 0. Any single thing pluses with 0, it's 0. So x squared plus c equal to 0. And here you have it. That was a mess. Sorry. Let's write that in another color. Like that. Yes. This is what we have. So this is how to write a pure quadratic equation. You write a pure quadratic equation like ax squared plus c equal to 0. There's no b here because there's no point of writing it because it's 0. And yeah, basically to spot a pure quadratic equation, it's basically where you don't really see a b or an x coefficient. Or x, I mean, you don't see none of them. So it's just ax squared plus c. So if there were like just an example of how you might just see a pure quadratic equation, so it would be like 5x squared plus 7 equal to 0. It's still a quadratic equation, but in pure form. Or let me give you another example, like, could be like 4x squared plus 9 equal to 0. That's also a quadratic equation, but again, a pure quadratic equation. And let's have one last example, like x squared plus 17 equal to 0. That is a pure quadratic equation. Let's go. So the next type of equation we're going for, or that is there, is let's see, it is hidden quadratic equations. So they go by their name basically. They are indeed hidden. So you can't really see them at first sight. So I mean you do see them, but you don't see them as quadratic equations. So let me give you an example here, like example number 1. X over x plus 1 plus x plus 1 over x equal to 6. Now that most certainly does not look like a quadratic equation. At least it doesn't look like that to me. So I probably looking at it at first, like if someone would be like, this is a quadratic equation, I would be like, no, like that's not a quadratic equation, doesn't look like it. You write a quadratic equation like that. Well, thing is, after doing some mathematical simplifications and yeah, mathematical operations, we can turn this exactly into that. Unbelievable, right? Well, that's true. So, here, let me get a bit down. So, let's just write that question again, and let's solve it and see if it's actually gonna be turned into that. Actually gonna be turned into a standard form of quadratic equation or not. So let's write our standard form right here. Okay, and let's see. So what we're basically gonna do is we're gonna multiply. We're gonna try to eliminate these denominators first of all, and yeah, basically solve it. So x plus 1 and x is going to be multiplied by all the terms, like it's going to be multiplied by x over x plus 1 and x plus 1 over x and 6. So it's multiplied with every single thing, so it's going to be x multiplied by x plus 1, and that x which is already in the numerator over x plus 1 which is in the denominator plus x and then x plus 1. It looks like an N. And then that x plus 1 that is already there over x, which is in the denominator, equal to x into x plus 1 into 6. Now what we're going to do is we're going to eliminate the ones that are similar. So this x plus 1 and this x plus 1 cross out, and this x and this x cross out. And now what we're going to do is we're going to multiply this x and this x together, and this x plus 1 and this x plus 1, and then this x plus 1, and this x together. Let's do that. So x and x is supposed to be x squared plus this x and this x is supposed to be x squared again. Let me just explain what it is. So x plus 1, x multiplied by x, it's going to be x squared. X multiplied by 1, it's going to be x. 1 multiplied by x, it's going to be x. And 1 multiplied by 1, it's going to be 1. Let's write that all down like plus x plus 1 equal to this. Now we're going to solve that. So it's going to be x multiplied by x multiplied by 6. That's going to be 6x squared. And then x multiplied by 1 multiplied by 6, which is just going to be 6x plus 6x. Oh, we went too much. Okay. Now what we're going to do is we're going to send all of the, first of all, we're going to simplify these two, and then we're going to send them all to the other side since this is bigger than that. And we're also going to simplify these two, by the way. So let's do that, like 2x squared plus 2x plus 1 equal to 6x squared plus 6x. Now we're going to send all of these to the other side, and all their like signs right here, they're all going to turn negative. Every single thing's going to turn negative, so it's going to be 6x squared plus 6x minus 2x squared minus 2x minus 1 equal to 0. And what we're just going to do is we're going to simplify 6x squared and minus 2x squared, 6x and minus 2x, and then we're just going to write this right here, minus 1, just like it is. Okay, so let's write that down. So it's going to be these two, it's going to be 4x squared, and then x, 6x, and minus 2x, it's going to be plus 4x. And it's going to be minus 1 after that, equal to 0. And that is our answer. And let's write again the standard form of a quadratic equation, which is ax squared plus bx plus c equal to 0. So this is what we said it would look like. What would look like, let's write the question again, which is, x over x plus 1 plus x plus 1 over x equal to 6. This turned into that, and that looks exactly like that. That is surprising. So that's basically the concept of a hidden quadratic equation. So it might not really look like a quadratic equation at first, but after simplifying it a bit, it literally looks like the standard form of a quadratic equation so well. There we go. There you have it. And bye for now. See you in the next episode.